So 8-5, like I said, rational expressions still. We're going to do addition and subtraction with them now, which you do very differently. So I kind of need you to separate the multiplication and division from the addition and subtraction, okay? With addition and subtraction, just think fractions, right? If I'm going to add two fractions together, I have to have a common denominator. So you kind of have to get in that realm of how do I get a common denominator with all these crazy numbers and expressions and whatever going on. So we're going to start real simple, just as a refresher. We're going to add two fractions, 2/3 plus 4/5. What do you do to add 2/3 and 4/5? What would your common denominator be? 15 makes the most sense. Okay, you could do other ones, but 15 makes the most sense. Prefer the least common multiple with this. So what we're going to do is we're going to multiply that first fraction. Remember, you can't just multiply by 5 because that's not going to keep our same evaluation, our same value of the expression. So we have to multiply by 1 by calling it 5/5, right? And then we have to multiply by 1 here by calling it 3/3. Is that coming back, fractions? So 5 times 2 is 10/15. 4 times 3 is 12/15. And now what do you do at this point once you have your common denominator? Add what? The numerator, right? Add your numerators. So add these together, you get 22 over what? 15. Keep the same denominator, okay? Adding fractions. That should be the easiest thing ever to you because you've done this for a long time in your life. We're going to just get a little fancier as we go. So now if I have 6/5x plus 4/5x, what do I do? Just add your numerators. You already have the common denominator. Okay, we already know it's going to be a 5x. 6 plus 4 is 10. So we get 10/5x. Can you reduce that? To what? 2/x, right? 10 divided by 5 is 2. So 2/x is as simple as you can go right there.
You're not really solving anything, right?
You're simplifying. Yeah, you're not solving for a variable or anything like that. You're just simplifying as far as you can. Why did I do that? So we have to get a common denominator. So if one of them is 5 and one is 3, the least common multiple of those two numbers is 15, right? That's the lowest number that both of those numbers can go into.
So if it was like 3 and 4, you would do 4 and 2 and 3.
Yes. Yep, you would try to make it a denominator of 12. Now, it doesn't always work that you just multiply by the opposite number, but you always can multiply by the opposite number. But sometimes there's a lower option. You'll see as we go kind of when those show up. But yes, you always do have the option of multiplying by the one on the other side over itself. Okay, letter C here. Okay, now here's where some of the issues start to happen. This is subtraction, okay? Maybe you want to set it up like this. Our common denominator is already xy, so just make it one big division bar and do x plus 5 minus 3x plus 1, okay? You're welcome to set it up that way if that makes more sense to you. You're just subtracting the numerators, but here's the deal. You're subtracting the entire numerator, which means that subtraction goes to both of these parts, right? So when we do that, excuse me, bless you, x minus 3x is going to be our first piece of it, right? We're subtracting. What is that? Negative 2x. And then 5 minus 1 is a positive 4. So it looks like this. Is there anything else you can simplify about that? Not really. I mean, you could say, I could factor out a -2 on top and break that down, but I think leaving it like this is the better option. So -2x plus 4 over xy. Do not get rid of those x's. You have an x here, but there is no x with this other piece of it, and you have to be able to divide by x in every single term, okay? And we can't, so you just leave it be, okay? Questions on that? Okay, here's where they get fun. We are going to factor and add. So it says simplify with this setup. Any thoughts on what we should do first here? What? I can't hear you. Never mind.
Maybe you could like pull out the 3 out of.
That's a good idea. Yeah, pull out the 3.
And then star method the other one. Because I think you're gonna get x plus 1 and x plus 4.
Okay, so if we do star method here, we're saying what can you multiply to get 4 that you can add to get 5. So you get 1 times 4, which means we have x plus 1 times x plus 4. Okay, I'm gonna rewrite this because I want it to be crystal clear what everything is, what's happening here. So give me a sec, I'm just gonna rewrite what we have right now. So currently we have x over x plus 1 times x plus 4 plus 5x over 3 times x plus 1. So far, so good? Okay, at this point, you need to find a common denominator. It seems a little tricky with this setup, right? It really isn't as tricky as it seems. Basically, what you're trying to do is you're trying to make both your denominators look identical. So if you look at the 2, we have in both of them an x plus 1, right? What do we not have over here that we do have over here?
3.
A 3. So what you're going to do is you're going to multiply by 3 over 3 on this side, okay? What do we not have over here that we do over here? An x plus 4. So you're going to multiply by x plus 4 over x plus 4. Why do I multiply by x plus 4 over x plus 4 and not just x plus 4?
Because x plus 4 plus x plus 4 equals 1.
Yes, you cannot just multiply by a random, like, oh, I'm just going to multiply by this. You have to multiply by 1 so it doesn't change the value, right? So multiply by it over itself. Okay, now with that, we can simplify a little bit from here. So we're going to do, I'm going to work below this now. 3 times x over 3 times x plus 1 times x plus 4. And you don't have to write this step down for me. I'm just trying to make it clear where everything's coming from. 5x times x plus 4 on top over here, and 3 times x plus 1 times x plus 4. Okay, do you see the common denominator? We now have a common denominator, okay? If you want to at this point, you don't have to write this step down. You can just write all the numerators added together over that denominator once, if that makes sense to you and you would like to take one step out of it, you can totally do that, okay? What should we do next?
Just add 3x and 5x. Let's make 8x.
You cannot add 3x and 5x. What do you have to do before that? You what?
1 out.
We can't 1 out yet.
Get rid of x plus 4.
No, that's what they're saying. We're going to 1 out the x plus 4s. We cannot 1 that out because up top here, that's an expression, right? 3x plus something, okay? That means this would have to be divisible by x plus 4 and this would have to be divisible by x plus 4, and it's not. So we cannot 1 out right now. What can we do in our numerator? Distribute, okay? So we're going to take this 5x times both of those. Excuse me. So this is going to be 5x squared. Well, let me leave the 3x for now. 3x plus 5x squared plus 20x. Okay, that's our numerator right now. But I'm not going to rewrite my denominator. This would all be down here still. I'm going to simplify that. So 3x plus 5x squared plus 20x is what? 5x squared plus 23x on top. And then all of this on bottom. Okay. So it looks like this. I'm great with you leaving it just like that. That can be your answer. If you prefer to factor out in that numerator, what could you factor out of the numerator right now? An x. So if you want to, okay, this is an option. You could say x times 5x plus 23 over 3 times x plus 4 times x plus 1, but there's nothing you can simplify any further. So I don't care which of these you give it to me as, but those are both acceptable answers. Okay? Questions on that? It's kind of a lot. Okay, can I move on? Anyone still writing from that?
So you should leave the bottom in like binomials.
Yeah, you don't want to FOIL and distribute and all that. You want to keep your common denominator as the common denominator in case there is something that eventually we could slash away. But there really isn't slashing that comes into play here. It's just nice to be able to see what is there. Okay, letter B. What shall we do first?
Pull out the 4 from
Yep.
the second denominator.
Pull the 4 out here. So that's 4 times x plus 2. And then star method down here. What can you multiply to get negative 12 that you can add to get negative 4? What is it? Negative 6, positive 2. So that's x minus 6, x plus 2. Okay. Looking at this now, can you tell me what your common denominator is going to be?
4 times x minus 6 x plus 2.
4 times x minus 6 times x plus 2, right? You need one of everything that we have in a denominator right now. So can I just work in this? Do you need me to rewrite it and then work on it? Is that, I don't want to confuse people, but I feel like, yeah. Okay, let's just work. And if I lose you, tell me. On the left side, what do I need to multiply by? 4 over 4, okay? 4 over 4. So now I'm going to have 4 times 2 on top is 8. My common denominator, 4 times x minus 6 times x plus 2. Okay, so that's my whole left side right now. Plus my right side, we know it's going to be 4 times x plus 2. We're going to multiply by what on top and bottom? Sorry, I should not write this right here. Let me write it right here. We're going to multiply by x minus 6 over x minus 6, right? Okay, so on top here, we're going to distribute this, 3x minus 18. And our denominator is going to be exactly what it is on the other side. Now, it doesn't matter the order you write it in. If you see it in this order, because that's how we're multiplying, you can leave it in that order. If it makes more sense to you to be identical to the other side, then make it identical to the other side. That's not a big deal, because in the end, you're going to simplify it one way or the other. So, okay, so now at this point, kind of treat this as one big division bar. We're just going to add our numerator. So what's on top?
3x minus 10.
3x minus 10 in the numerator. 4 times x minus 6 times x plus 2 in the denominator. And there is nothing else you can simplify there. You cannot one out your x's. You cannot reduce the 10 and the 4 because you have the 3x, right? 3x minus 10, that whole thing would have to be divisible by 4 or something like it, by 2. Questions on that? Gina?
I have a question with when you were talking about it. So like this when you know like what's multiple.
You need one of everything that you have in a denominator. So when we get to this point where we have, here, let me highlight so you can see which ones so this is what we factored on the left side, and this is what we factored on the right side. So we had a x minus 6 and an x plus 2 on the left. We had a 4 and an x plus 2 on the right. So that means to make them identical, we had to multiply by 4 over here, and we had to multiply by x over x minus 6 on the other side, so that my two denominators were exactly the same.
Oh, so since the left side didn't have 4, that's what you multiplied by.
Yeah.
Since the right side was
The x minus 6, that's what we multiplied by. Yeah. Okay? Okay, why don't you try this one? See what you can do. Notice these are all monomials in the denominator now. There's no binomial, there's no factoring involved. So it's really just multiplying by something. Here's your hint. You're only going to multiply one side. Your common denominator is already visible there. See if you can figure that out. Okay, I realize you might not be there yet, and that's okay. Tell me what you're going to do first. So you already said your common denominator is this. How can you make x look just like that? What do you have to multiply by? By what? 3y squared over 3y squared is what we'll multiply both things by, right? 3y squared and 3y squared. So when you do that, Isaiah asked a good question. Do we have to distribute that? What do you think? Yes, this is an expression that 3y squared has to get multiplied by both of those things, okay? So on top right now, you have 3x plus y cubed plus, and now we're going to distribute. 3y squared times 5x is 15xy squared. 3y squared times a negative 4y is a minus 12y cubed. Okay, and that whole thing goes over our common denominator, 3xy squared. Is there anything else you can do? Sure about that?
Can you divide 15?
Can you divide like the 15xy and the 3x?
You cannot. Okay, so you could, if you could divide every term by 3. Can you divide every term by 3 right now? No. So you cannot get that 3 out of there because you have to be able to do it with everything. Whenever there's an addition or subtraction, that's a new, like, I got to be able to do it this one and this one and this one and this one. Okay, so we can't do that. There is something you can simplify still, though. Cubed, y cubed, yes. You can add, well, subtract, really, those two together, y to the third power minus 12y to the third power. So you have a 3x, you have a negative 11y to the third, a positive 15xy squared over 3xy squared, okay? Now it's so tempting to say, I should be able to reduce this, but because you're adding and subtracting, you have to be able to do whatever you're doing here to all 3 pieces, and we cannot. So you have to just be done at that point. I know it sounds wrong, but if you can't do it to everything, you can't do it to anything. That is your answer. Questions on that? Yeah.
I just have like a question in general. Like, if there's 2 things that have like to the squared power, which one would you put like first? Because
I usually put it in alphabetical order. Mathematically speaking, they say alphabetical order is kind of the default. But like if you wrote negative 11y cubed plus 12x cubed, I wouldn't mark you off for that. Good? Okay. Subtraction. Subtraction is really the same thing, but gets done wrong a lot more often because people forget to distribute that negative sign, okay? So just be careful when it comes to subtraction that you're going to distribute the minus. Maybe you want to make a big old note to yourself. Distribute the minus. Okay, don't forget to do that. So letter A here, what's the first thing you got to do? Distribute the minus. You have a common denominator already, right? So all you have to do is subtract. So we're going to think of this as 6x plus 1 minus 3x plus 2 all over x minus 5. Okay, so we're going to distribute that minus sign. This is going to be 6x minus 3x. So that's 3x. Then it's 1 minus 2 is a negative 1. So you have 3x minus 1 over x minus 5. Can you one out your x's right now? No, because everything has to be divisible by x if you're going to get rid of it, and not everything here is divisible by x, okay? So your answer is that. Distribute that minus. Last one. Do you want to try it on your own? There's some factoring, there's some subtracting. Okay, well, if you want to try it on your own, ignore me. I'll talk you through it. What should we do first here? Take what? Yes, factor out the 5. So you're left with y squared minus 25 for that one. What do you do on the next one? Take out the 3. Okay. What do you do with this? Y squared minus 25. It's a difference of squares, right? So one's plus, one's minus. We square root them both. So right now, on the left side, you will have 5 times y plus 5 times y minus 5. Okay. On the right side, you have 3 times y plus 5. We need what? A common denominator, right? Okay, so look at what we're working with. This on the left, this on the right. What is our common denominator going to be? 15. What else? Y plus 5, y minus 5, okay? So if our common denominator from these two is 15, y plus 5, y minus 5, you got to think about what do I have to multiply both sides by to get there. Okay, so I always question what is the best way to write this for you guys so I'm not terribly confusing you. I'm going to kind of start over off to the left here. So 7y over, we just said we want it to be 15, but I'm going to rewrite it like this so I can show you what I'm multiplying by. Okay, so this is essentially where we're at right now. We said we want 15 y plus 5, y minus 5. So to make the left side that number, what am I multiplying by on top and bottom? 3 over 3. Okay. On the right side, what do I need to multiply by? 5 and y minus 5. Okay. All right, so now we're going to start to simplify. Up here, you have 21y. I'm going to make it one big division bar. I'm just going to write the denominator once now. 15 times y plus 5 times y minus 5. Okay, so it's 21y. Now what operation? The minus, right? We're subtracting here. So 21y minus, and now what do you do over here? We're going to multiply. 4 times 5 is 20 times y minus 5. Okay, now we're going to distribute that. 20y minus 100, but this is all in parentheses right now. We have to subtract this whole thing, right? Subtract the whole right side. So subtract 20y minus 100. When you subtract 20y minus 100, if we simplify that, that becomes 21y plus or minus? Minus 20y plus or minus? Plus 100. Minus a negative 100 is plus 100, right? So simplify that again. 21y minus 20y is y plus 100 over 15 times y plus 5 times y minus 5. Can you reduce any of that? You cannot, okay? So that is your final answer. So you really have to just remember that multiplication and division and addition and subtraction are very different things, right? No slashing away with these. Don't just start getting rid of things because you don't like them there, okay? You can't slash unless every single term is divisible by the same thing, okay? Kate.
Where did you get the 100?
So I did 4 times 5 right here and got 20, right? And then that 20 got multiplied by the y and the 5. So 20 times 5 is 100. And because we're subtracting a negative, that's plus a positive, right? Minus a negative becomes plus 100. Questions on that? I know it's a lot. Okay.